I apologize for not getting out a video last week. We were out of town for several days and some important paperwork that had to get done. Anyway, I hope I make up for it this week. We got a 1954 Gorton master mill here. We're going to do some work on for the power press over there. One of the bending molds that I've used for years and abused, it's just pretty much done. So I've got a little dinky project out there I'm going to do for a fella, and I'd like it to turn out a little bit better than what that bending die is going to be capable of. For starters, it's too short for the bends that I need to make, and there's a lot of damage on the upper rails and stuff. You know, a lot of this stuff we make out of mild steel. It's not tool steel. It's kind of made as a consumable. It's made for a job at a certain job at the time, and you use it, and then it just kind of becomes part of the woodwork, and you use it and use it and use it, and one day you go, wow, you know, I've been using that for 15, 20 years, and I just flat wore it out, and it's time to replace it with something that's more suitable for the job. Anyway, let me get this put away, and we'll move on. There was something else also. Cycle Buster asked a question about the lathe, and we'll run over there and I'll run through that real quick for you about spindle speeds and that sort of thing. So let's do that real quick. I answered them in the comment section there, but it's something that's kind of interesting about gear ratios and spindle speeds, stuff like that, that you guys might be interested in too. Okay, I'm going to run through this fairly quick, so you know, I hope I don't outrun you guys. But anyway, Cycle Buster asked about spindle speeds. So to determine that, I mean, I was just going to, you know, say something off the cuff, like, you know, 500-600 RPM, and I would have been pretty close. If you're really wanting to figure out things a little bit closer than that, say you're working on some kind of exotic metal or something like that, where you kind of need to know where you're at, or maybe you just want to know. Start with your motor, and on just about all of these motors that I've ever seen, unless it's been knocked off or whatever, there's a tag on there that'll tell you what the motor speed runs. This one, you can run it on two different voltages. You can run it on 220 or 440. I run it on 220. Three-phase that I manufacture my own three-phase in the building because this old building does not have it. I don't run a business here anymore, and so the cost-benefit ratio is way off on having it installed here and whatnot. So at any rate, I've got a spinner up there, and if any of you guys are interested in that, I will show it to you and tell you how to wire it. They're very simple. I think I've got like $1.298 in that one. But I had the motors, so I mean that. Anyway, back to this. This one turns when it's on 220 three-phase. On 440 it runs slower, but on 220, on what I have it wired at now, it runs 17.25, 1,725 RPM. Now, this up here is an old Harley Davidson 3-speed transmission, and it's got neutral in between each gear, which is kind of crazy, but they did that on some of them old Survey cars and stuff like that, I believe. Some of the motorbike guys that are really up on that stuff can correct me. That's fine. I don't claim to be a guru on Harley Davidson stuff. You know, I've ran a bunch of them. But anyway, when it's in second gear, the 1935 to 1940 ratios in second gear were just a hair under 1.6 to 1. In 1941 to 73, they actually made that series of transmission. I didn't know that. They were a hair above 1.6 to 1. So let's just average it out at 1.6, because I don't know the exact year of this transmission. So we'll just call it 1.6, and if we call it that to 1, then you divide that out and it'll give you 0.625, and you take that times your 17 1/4 gives you 1,078 RPM. It brings it down, you know, roughly 30%. Let's just say that. And it's easier to comprehend that way for me too, because I've got about a 4-inch pulley up here. Now I haven't done exact measurements on this. It's all roughing it in. If you need to know what your machine is doing, you got an old machine like this, then do the due diligence and do the measurements. Me and what I do, I don't need to be that exact, but it's about a 4-inch pulley up on top here that old Jess put on this transmission, and then about a 12-inch pulley on the bottom. So there you go again, gearing it down about 60%, right? You know, in thirds, so to speak. I'm just roughing this out. So second gear, when I'm in second gear, which I run it in most of the time, it runs about 430 to 450, 60 RPM on the spindle here. Third gear, which is direct, then you're running at 1725 right into the tranny and out to the pulley, because it's direct then. So then you do your math again, your thirds, 30%, puts it at about 690, so 700-ish, right around in there. So in second gear about 450, right around in there, and third gear, which I don't run it that way very often. This is a 16-inch chuck on here. It's heavy. That's pretty fast, you know. I mean, for an old machine like this, you know, it's over 100 years old. I'm not even close to that, and I don't want to run that fast. So there you are. Those are the speeds. This has got the big old brass bushings on the spindle, front and back. And I think I mentioned that in one of the other videos. It doesn't have roller bearings. If it had roller bearings, you could probably run it faster, maybe, but you got other gears and back gears and shafts and stuff on here to consider. Not everything, just, you know, one of the machinists down the street here, God rest his soul, he did one of these old Hamilton styled lathes for a guy and put bearings, lathe bearings on the thing. And I thought, boy, what a great idea at the time. And then, and you know, he was doing what the guy asked him to do, and I'm sure it turned out great, but there was other things to consider. You know, these shafts on this particular machine, this machine's 13 freaking feet long, so these shafts, by the looks of things, are probably somewhere in the neighborhood of 11.5 to 12 feet long. Your lead screws and stuff, they're so long that they put these carriers on the lead screws to help support them so they didn't get to banging around. You know, speed's fine and everything, especially on the newer machines and stuff like that, where you can get away with that. These old machines, you know, they were built to run high-speed steel and stuff like that for cutters. I retroed a carbide tool holder on this old lamp post, and I like running that. That works good for me. But I still switch back over to high-speed steel from time to time. It depends on the material and the job and what you're trying to accomplish. So anyway, those are things that you guys got to, you know, determine for yourself. But the question was asked, so I'm going to try and edit this down so it doesn't seem so lengthy. But there's the answers. I would have been pretty close if I would have said 500 to 600. RPM. So there you have it. 450 second gear, around 700 third gear. Okay, that's the simplified version of it. All right, hope that didn't bore you to death, but there's some really that simple math that you can figure out where your machine's running at. All right, let's get on with this other project over here, building this die for this press brake, and we'll show you some work on the milling machine.